Thank you. Uh, Good afternoon, good morning, good evening, ladies and gentlemen, wherever you are. My name is Grare. I'm responsible at Lhyfe for the international expansion of the company. And in this short presentation, I will go deeper in the role which hydrogen can play in the future of energy and also in the energy 4.0. The oil industry has brought us over all these years. We have been around with them, access to energy at any time, also a very relative cheap way to transport ourselves, thousand and thousand kilometers around the globe. They brought us also the possibility to consume, even more consume, and a massive overconsumption. And also what they brought us was a disastrous report, which was made and published last month by the IPCC. I'm not going to go in detail of this report. There is enough publication available about this. You can read through all the 1,000 papers which have been published by the scientists, but there are also very good summaries available of this report. But instead of oil and gas, we have alternatives. They are known, and we are already a couple of years with them on the market, and capacities are increasing every day all around the globe. Prices are massively reducing, and in some parts of the globe, the cheapest way to make electricity, like solar PV or like wind energy. On the other hand, the oil and gas companies, the traditional energy companies, through their lobby, they keep on trying to explain to us that we should not move too fast. Because all these renewable energy, they have fluctuation. There might be days without wind, without solar, then there is no production. So there is intermittency. And what the oil and gas industry is trying to explain, and guys, don't walk too fast, because you will still need us for the coming decades. Because look at that on the left side here. We can put it in big tanks, and it's all time, every time of the day, we are available to deliver energy. So, but I think the fact is that we are spoiled people, actually. We eat strawberries in the middle of the winter, wherever they're coming from. We enjoy skiing even outside the winter season, in autumn, for instance, when there is no temperature to create any snow, but it can be made artificial. We don't care about when we switch on our wash machine. We switch it on when it is needed, actually, then. And some of us tend to buy all kind of, I call it between brackets, crap, which I think nobody needs it, actually, then, from those kind of websites which you have here. And the thing is that if you buy 8 or 9 of those very, very cheap parts, actually, they will all shipped in pieces, 8 to 9 packages you get from China to your home place. So the question is, on the one side, we are spoiled because somebody learned us that everything should be available at any minute when you want to have it. But the question is here, are we not able to live with this intermittency? So when there is no sun, like in a cloudy day here on the left picture, and no wind, maybe it's not a good time then to charge your electrical vehicle. Maybe it's a good time to work down from home, so to stay in home office. The industry which is using renewable energy, and here's a picture from a steel industry, which has a furnace running on renewable electricity, then they learn to live with this intermittency. So when there is no sun or no solar, they reduce their production output of steel, and they ramp it up again when prices are that low, because there is an excess of electricity in solar and wind. So also here, as a consumer, there is technology available, actually, to manage even fluctuating electricity prices, when there is not enough electricity, then the price might be high, to manage really to store electricity when the prices are at lowest. Of course, I do understand somewhere that some people are living in a situation of power poverty or near to power poverty, and a fluctuating electricity price makes it even more difficult for them to live. And I think that is where governments has to set up support schemes for those people in those situations. But I think here, living with this intermittency and trying to change how we plan our day and make it more dependent from nature, that is where I believe that Energy 4.0 should come into place. And we have all technologies. So we have, like I said, renewable energy, we have bikes, we have even electro bikes. So no problem anymore to go 30 kilometers away to work with the bike. You will not come totally exhausted at your work. We can do very good isolation from homes, heat pumping, etc. All technology which is available, and also the digital technology to bring the Energy 4.0 into place is also available. We have technologies like blockchain, etc. It's all there. It's a matter of bringing together and execute it. Because what we, as a human species, has to do we need to stop our predator-prey behavior. We need to stop by eating in the earth, because there is only one planet, and we are just eating it up. Where we need to come to is a shift to contributing, to live together with this planet, and to adapt our behavior to the nature and how the nature is behaving. We cannot change the nature. It's too big. So this short presentation is about hydrogen. And let me now switch to hydrogen and what the positioning of hydrogen is in this energy transition, in this future energy system, in this Energy 4.0. So hydrogen is, as you see on the left, on the 5 bars, the only energy carrier which doesn't have carbon. So the highest carbon amount is in wood. It goes further down to coal, then natural gas, and then hydrogen. Today, there is in the world consumed about 70 million tons of hydrogen per year. And the majority of these is used to make ammonia. And this ammonia is made to make fertilizers. And another big part of the hydrogen which is today produced is going into refineries, which is done for the desulfurization of our petrol, of our fuel. Because if we would not be doing that, you would get again this kind of acid rain, where many countries in the 70s and the beginning 80s has been suffering from, with black facades of buildings, etc. And many forecasts from many different institutes say us that the global demand for hydrogen will be exploding in the coming years, because there are new applications coming into this. And then, as you see, one new application is the transportation, where hydrogen is mainly used for heavy duty vehicles, so trucks and buses, etc., with the advantages compared to batteries, that it is much lighter. So if a bus or a truck has to carry 5-6 tons of batteries with it, in the case of hydrogen, it can be done with less than 100 kilograms to get the same result. We'll also be seeing that hydrogen will be more and more used to replace certain feedstock in the industry, which is today extremely polluting, for instance, in greenhouse effect. So, for instance, coal will be substituted in the steel industry. also for the oxygen reduction of the ore. So these are industrial applications where we see that hydrogen will come more and more into place. So, and that is where the big increase is coming from, besides with some new applications. Now, how is hydrogen made today? Hydrogen is actually only 1%, you can say, all over the world is made as a green material. So the rest is made from coal, from gas, from oil as a kind of captive process. So only 15% is on the merchant market, and all the rest is, let us say, captive. Now, if you make hydrogen in the classical way from methane gas, and that's a process called steam methane reforming, that would emit about 11 to 12 kilograms CO2 per kilogram hydrogen. And then we do not talk about the methane leakage, which you have in the pipes, all the way from where the source is of the gas up to where it is consumed. If you would be taking that into account, it is similar to adding about another 10 kilograms CO2 emissions, because the impact from the methane gas compared to the CO2 is about 84 times. If you make then what is called these days more and more is coming in the press, blue hydrogen, where you capture the CO2 from your steam methane reforming, so you use the Grare concept and you capture the CO2, then you will go down, a little bit down to 7-8 kilograms CO2 per kilogram. There was recently published a new document with some interesting new findings, where I put it here, the source. But of course, also here, again, you have to add the leakage which you have from the methane gas, and which might be even a bit more than the 10 kilogram, because in the case of blue hydrogen, you consume more methane gas to make the same amount of blue hydrogen. So the way actually to make the most clean hydrogen is to do it in a green way by using electrolysis connected with renewable energy. Of course, the renewable energy is also not completely free of CO2. That is what we need to take into account. We did, so we took a mix on onshore, offshore, and also some solar PV. And you see there the Chinese PVs, because the wafer making is very electricity intensive. And that is where in China is not everywhere used renewable energy. The majority are not using renewable energy, and that's the reason why we come to a slightly higher CO2 emission from using solar PV versus offshore wind. But anyhow, we stay here under the 2.5 kilogram CO2 per kilogram hydrogen that you produce. So technology is there. It is the willingness to do it. So we believe it's time for a change. And that is where we come in place as a company, Lhyfe. So founded in 2017, we really started the business in 2019 after our seed financing done. In a very short time, we ramped up from 15, 18 people to today 52 people, and plan to have 100 people in our company by the year end. So we have, in the meantime, a pipeline from more than 1 gigawatt. And we see ourselves as a producer of green hydrogen. We only do green hydrogen made by renewable energy. We are a group of young, ambitious people, and all the spirit, we want to change things now and not tomorrow. So, and as such also, we do not participate in what I call the world chip announcements from the big oil and gas companies, utility companies, who is announcing the largest hydrogen production facility to be built after 25 or 2030 or 2040. This is no meaning. So what we work on things which can be executed in the next few years, that will really, if you want to be impactful, you have to make things which can be realized now. Because again, the IPCC report was very clear. We do not have to wait after 2030, 2035. You have to start now. And so one example is we started in August our first plant in France, one which is near to the Atlantic Ocean. That plant is directly connected to a wind farm, and also we use the seawater to do the water splitting in the electrolyzer. We have also announced, and we are today in the detailed engineering, that we're going to build a 24 megawatt plant in Denmark, which will be already next year operational, and further scaling up and adding another 100 megawatt operational in 24. And these are things we are really executing already. We are doing the detailed engineering. We are in the preparation of the permitting process, etc. And we do not do this only onshore. We do also offshore. We will be the very first in the world making hydrogen on the sea. And that will be happening in the second half of next year at a location about 26 kilometers away from the French coast in the Atlantic Ocean. There is already a Vestas floating wind turbine on site, and we will be putting on a vessel structure an electrolyzer direct connected to the wind turbine, and as such producing hydrogen. And very soon, I think it is in the next few weeks, we will be making announcements, also things very soon to be executed, talking about next year and the year after, the delivery of hydrogen to Deutsche Bahn, the German railway company, Snam in Italy, and Tenaris, the big steel company in Italy. What we do is, this is our scope. So we develop projects from scratch. We talk with potential off-takers to help them how to decarbonize. So which means we have a group of salespeople which go in the steel companies, which go in the glass companies, which talk with local communities, etc., how to find ways to decarbonize by the use of hydrogen, where we come in place and that we are their preferred supplier of the green hydrogen. And when we have a couple of those off-takers, we start developing a plant. It might be in the region, might be a little bit more far away. We figure out how we can bring the hydrogen to them by truck or by pipe. So that's part of the development. Then we have a project which is ready to start building. We get this finance. The construction, the EPC, we do by ourselves. That is the reason why we have today already more than 50 people, and by the year end 100 people. Many of them are process engineers, electrical engineers, etc. So we buy electrolyzer components from the typical electrolyzer manufacturers, but these are just a number of selected components. We design our own plant. We have our own software running onto these to optimize the power consumption of the plant. And these all with only one objective, is trying to find a way to bring the price down for the green hydrogen per kilogram. Because at the end of the day, we need to be a certain way competitive. Of course, there are subsidies, but it doesn't mean that we just can lay back. We have to work on the cost, and we have to make it competitive versus the gray and the blue hydrogen. Exactly the similar way, like in the solar PV and the wind, also there it needed to be competitive in pricing versus the traditional way to make electricity. And then we do the day-to-day operation. We run the plant. We provide our customers with their green hydrogen. And that is what we see as our role in the future energy system. It's just a part of this. It's much more building blocks, of course, than these, what I have been explaining. But also, I believe our role in energy 4.0. I think this all has to come somewhere together, the merging with the digitalization. And that is no science fiction or whatever, is really clearly shown on this picture, this slide. This is a plant in Norway, in a place called Rjukan, which was operational in 1927. That was a 300 megawatt installed electrolysis capacity. And at this plant, they were producing hydrogen, which was then made to make ammonia for Yara to be used in the fertilizers. This plant has run about 60 years and was then dismantled because Yara started then buying ammonia on the free market, on the merchant market. But it shows actually that it is all possible on a big scale to make hydrogen. It's just a matter of getting it done, executing. It's not more than that. And that also cars running on hydrogen was no science fiction. Shows this picture from 1933, also in Rjukan in Norway. Of course, this was not with what we know today, the fuel cell, but anyhow, the idea to use an alternative fuel for a car was also already in mind at that time. Why we do all this? Why I say all of this, what I have told you the last 20 minutes? Because we believe we need to do it. We need to provide a better future to our children, and we cannot leave the planet and the world like it has been represented by the IPCC report last August. We need to do our effort now. Thank you very much.
Hi there, I am Mathieu Guéné, the founder and CEO of Lhyfe. Lhyfe is a company that produces hydrogen, but not any kind of hydrogen, only sustainable hydrogen. How do we manufacture sustainable hydrogen today? We use electricity from windmills, and we pour that electricity directly in a machine that produces hydrogen. And the only thing that is emitted by our factory of hydrogen is oxygen. It means that today, women and men has invented a way of producing hydrogen, this new fuel for the mobility, without emitting any greenhouse gas, only oxygen as a byproduct.